But today we're going to talk about bill of materials and bill of process. Bill of materials is probably familiar to most people. Bill of process is a little bit less common, but still very, very important. For those of you who don't know me, my name is Matt Berlinich. I am InnovationWorks Manufacturing Program Manager. Also part of the hardware team, we have Jesse Mazzoni, who is the Alpha Lab Gear Program Manager, and Mike Formica, who is the Managing Director of all of our hardware initiatives. This program is being operated in partnership with NextCore, a similar organization to Rochester and Catalyst Connection based out of Rochester, New York. They developed the original curriculum, ran it, we helped improve and add to it, and now we're running version 2 of that curriculum. Feel free to put your cameras on if you are comfortable with that. I feel like it helps engagement with other participants, but if not, no worries. I'm not sure if you can change your names in Google without changing your full settings, but give it a shot. This program is sponsored by the NIST, National Institute of Standards and Technology, Manufacturing Extension Program, or Manufacturing Extension Partnership Program, which is a network of nonprofits in various different regions of the United States, whose sole mission is to help improve the businesses of manufacturers all across the country. So our local MEP is Catalyst Connection, who is in partnership with us on the delivery of this Pittsburgh portion of the program. The program is also sponsored by NISTAR, the New York State Division of Science, Technology, and Innovation. As I mentioned before, Rochester Institute of Technology, Fuse Hub, InnovationWorks, and Catalyst Connection have all contributed materials to this and are sort of partnered on various aspects of the programming. Today, we're going to talk about bill of materials, bill of process. Last week, we talked about product development and specifications, and the recording of that is updated in the folder. Let me know if you don't have the link. Next week, we'll talk about cost and risk management, which is a really important topic, but also very essential to have a decent understanding of your bill of materials and bill of process in order to have a full grasp of some of those concepts. So today we'll introduce you to the bill of materials and talk about different types of parts that are on it, as well as essential and nice to haves, and how it connects into other documents. We'll also talk about the bill of process, which in general covers, I like to think about 3 different types of bills of process: process flow diagram, an SOP style bill of instruction, manual bill of process, and then what I would call a costed bill of progress, which is like a tabular form of how much labor is embodied in your product. Recap from last week. PRD stands for your product requirements document. Every customer requirement that you end up documenting from your customer discovery should be translated into a technical specification for your product, and therefore then documented in your PRD. These specifications can cover, but are not limited to, functionality, durability, reliability, aesthetics, certifications, and more. The specifications portion of this should be quantitative. They should have a target value and then an assigned maximum or minimum, or both value for acceptable values. These specifications should be validated and verified through a quality test, which ideally would be linked, would be its own sort of document, which we'll talk about later, the quality test plan, and you can link specific sections of that into your PRD so that it's all tied together. So just for the sake of the data nerd in me, if you made a stab at filling out the PRD, just drop a note in the chat. I'd love to see sort of how many people actually took a stab at it, or maybe updated one that you already have. But I want to try to get through this so that we can actually have a good discussion at the end with some questions. So Step one in this general product development process or product definition process, I'd like to think about it in terms of your customer requirements. So do you have a good understanding of what those customer requirements are? The next step is, have you translated those requirements into specifications, which can be quantified and you are attempting to hit and validate that you hit them? The next step is your bill of materials and your design package. And what I like to think about with that is this is the physical embodiment of your product. Everything that physically exists for your product should be documented in this BOM and this design package. The bill of process and SOPs, I like to think about that as the sort of the labor, the non-physical aspects of your product that are embodied in your costs or buried in your costs, and oftentimes unidentified in your costs. First, we will talk about bill of materials. So, textbook definition is a comprehensive list of all of your parts, systems, and materials required to build your product. It's not that unfamiliar of a concept. Actually, you've definitely seen one before if you've ever looked at a recipe. A recipe is actually a good embodiment of both the bill of materials and the bill of process. Once you hit that little button on the recipe website that skips all of the origin story of where the person came across this recipe while they were traveling in France and shit like that. The actual list of ingredients, like 1 egg or a third of a cup of melted butter, that would be your sort of bill of materials. The written out portion of how you assemble those into the final product would be your bill of process, or an SOP style bill of process, standard operating procedure of how you assemble the ingredients, is what that stands for. So this bill of process can include a whole lot of different things, from, you know, the name and a description of the bananas, the quantity, amount, the measurements, a supplier or a sort of brand. And all of these have analogs to every different type of product that you might be manufacturing. So at a bare minimum, your BOM should include your own unique part number for every component in the BOM. And I can sort of walk through examples of why that is pretty important later. A name for the part, a description, quantity, the cost per part, and then the extended cost, which is a sort of subtotal cost. So if you think about it in terms of, like, I need 6 inches of wire, you would put the quantity as 6, the units as inches, the wire cost as price per inch, and then your subtotal is, you know, so 60 cents if it's 10 cents an inch or something like that. We'll go through this in greater detail when I sort of walk through an example later. Other things that are good to include, your supplier, part lead time, the part number or of that particular supplier or manufacturer, the manufacturer's part number, the ordering method, whether it's generic or assigned, and then comments or notes for internal use, which we'll talk about a little bit more later. So what are BOMs used for? Why are they important? This is probably not even an exhaustive list, but just some very important ones. They're essential for maintaining product consistency. They're essential for traceability, which is especially critical if you're in a regulated industry like medical or aviation with the FDA and FAA. It's essential for understanding and tracking your cost of goods sold. And that comes at various different stages depending on where you are. If you are still in the phase of estimating and finding out whether or not you have a business or your pricing model works out, it's good for estimating and making design changes. If you are later in this process and you're looking for suppliers, it's good for getting quotes and managing quotes. And then further down the line, it's good for optimizing the design of your product, the production of your product, or the supply chain. So it can also be used to manage your supply chain to avoid production delays. And as I mentioned before, cutting costs once you get to the stage of like truly optimizing. And an intelligently organized BOM can make that a lot easier than sort of cross-referencing a ton of different documents, which I like to often say are become orphaned, where they're lost in the ether. You don't know who has them or who owns them if you use Google Drive, whether it's shared with you or not, all of that kind of garbage. So last one is to communicate and organize your components. Really, at the end of the day, this is a communication tool, either with you and your past self and your future self, with you and other people in your organization, or with you and your supplier network. So an essential part of that is linking specifications. So we talked about the product PRD, product requirements document, and the specifications which should be documented in there with respect to the overall product and how it performs. So to use my business as an example, again, the ice mold, does it actually make clear ice? Now, if I was documenting a part level specification, does the silicone tray fit into the water vessel? And that would have its own specification, which I would link on the BOM for that part, but not necessarily have to call out every one of those in the overall PRD. So another important thing to maybe potentially include in your BOM, especially depending on the stage of your product's development, is types of parts or categories. So COTS is a common acronym for commercial off the shelf, which means literally you buy it from Home Depot, Amazon, Walmart, a distributor, anywhere like that. Standard parts. Then there's custom parts, which are things that you sort of design or develop, or you've had made specifically for your product. Fabricated parts are, again, just a sort of specific nuance to a custom part. I like to think of them actually as being fabricated from bulk materials. So if you made a support structure out of plate steel, that I would consider a fabricated part as opposed to an injection molded part, although that's listed as an example here. It's more of for your own understanding of how you categorize your parts anyway. Electronics, and then the last two on there, which I think are pretty nuanced, which a lot of people don't necessarily include or in their BOM or document accurately, is consumables and raw materials. So I would put consumables down as something that's like glue or tape, where you buy a big jug of it. You're not exactly sure how much of it you use on each part. You don't even account for it in your costs because, you know, you spend 20 bucks on it and it lasts you for 200 units. And you don't really know or keep track of that. But as you go to scale, that can become a critical thing. Also, if you have tight margins. Another one is raw materials. And this would be important for somebody actually like Adam with your grill, where you're plasma cutting out of a sheet. This is an important way to document your embodied costs in that, because you buy the sheet of material and then you cut your parts out of it. And so knowing how many parts you get on a given size sheet and how much that sheet costs, documenting all those assumptions is critical for capturing what your ultimate per unit cost is, because it's going to vary wildly if you're walking to Home Depot and buying like a 1 foot by 1 foot piece of steel versus a 4x8 or a 5x10 sheet from a distributor, or letting your manufacturer supply that part. But you still want to ultimately track that and get an idea of what your sort of offcuts, wastage, and errors are to embody that into your ultimate costs. Now, that brings up another really critical, I think, portion of the BOM, which a lot of people miss, is assigned versus generic parts. So an assigned part is, you can think of it as one that if you were outsourcing this to somebody else to make, that you would say, you have to buy this exact part. Like you could even link to where you would order that. It should really have, as a result of that, who is the supplier, what is the supplier part number, or any essential ordering information for that specific component, because it's critical to the functionality of your overall product. So that would be a sort of PRD specification a PRD specification would then hinge on using an assigned part for a specific role. The opposite of that is a generic or a commodity part. This is like resistors or angle iron, plate steel, things like that. They are things that are commercially commonly available. You can go to Lowe's or Home Depot or Amazon or Metal Supermarket or Alro to buy metal. You can go to DigiKey or Mauser or Arrow to buy your electronic components. But the important part is if you use a generic designation for a part, you should absolutely specify what is critical to the functional of your part about that part. So if you just say steel, but it needs to be heat treatable steel, then a manufacturer can end up using the wrong material and your product won't work at all. What's up, Adam?
Just a quick request. Can you remind me what PRD stands for, and maybe when you're using acronyms, just the first time you use them, just remind me what they are. So there's a lot of them in these in this kind of stuff.
Yes. That's a great suggestion. Thanks, Adam.
Thank you.
PRD stands for Product Requirements Document. So that was essentially session 1 of this curriculum is how do you document, where do you document the functional requirements of your, or the requirements of your product to satisfy your customers' needs, and then how do you translate into technical specifications to make sure that a manufacturer makes a product that meets those customer requirements. Okay, so another critical thing that we had mentioned before to have on the BOM is a part number. This is your internal designation for that part, and there's a whole lot of ways to do it, but this is an example from our partners at FuseHub and from the Build for Scale curriculum, which you'll see in that overview that I had shared or added to the folder of all of the shared documents, that there's a bunch of different additional presentations that cover specific topics linked there too. That's the Build for Scale curriculum. But you can see from this example here that you can structure your part numbers to embody a lot of information in the part number itself. It can even be used to differentiate different components. Like say you had the same wire, but it's cut to 2-inch lengths and 6-inch lengths. You can denote that as different part numbers so that you can then differentiate when virtually everything else about that part is the same gauge, supplier, everything about it, but you can then filter based on that. So things to keep in mind in general about all of these different nuances. Assigned parts tend to be more expensive in both cash and time because it takes time for you to design it, to find a supplier to make it, to order it, to manage that supply chain. Generic parts tend to save you time and money, but they increase the risk of miscommunications and supply chain issues because of what I'd stated earlier. If the manufacturer isn't aware of what's actually critical about that generic part, and then they can order the wrong thing, or maybe they think that you're responsible for ordering it and warehousing it and sending it to them versus them managing that supply chain. Nuances to make sure that you manage and consider. So custom parts versus COTS, or commercially available or commercial off-the-shelf components. COTS is minimum order quantities. What's the cost of it? How generally custom parts are more expensive and have higher minimum order quantities. The supply chain management of it is harder, but with COTS parts, you can add redundant suppliers much more easily. Another thing to consider is, as we talked about before, the managing your raw materials. and making sure that you're actually accounting for waste and offcuts when you change a design or change the spec, say going from using like a 2x2 sheet to a 4x8 sheet of material. So as I had mentioned earlier, and we'll go over this again in greater detail with the example, but having your BOM organized in a way that is intelligent can aid you in sorting based on your total BOM cost and identifying areas of improvement or optimization, identifying where your most expensive part is, figuring out ways to drive the cost down or optimize your production rate, and also just ultimately figuring out if your unit economics are even feasible. Now, this is an example of a subset of a bill of materials from a case study that was done by FuseHub. This is a garden hose reel, and it was originally like a blocky, solid wall, low molded components. And so they had identified that they were able to take out a significant portion of the cost because just the outside pieces accounted for 59% of the total BOM cost. But because they were able to quickly reorganize their BOM based on this percentage of BOM cost, and their part numbers are all denoted by 224 to 2249 to start and group those components, it made that particular analysis much easier. So to that effect, I would highly recommend using an indented BOM format, which basically allows you to really quickly and easily identify and categorize your major systems, and then your subsystems, and then your second level subsystems of your overall product. And I'll sort of walk through that as an example here. I don't like this as an example, but it can be useful for just seeing how somebody would fill out this particular style of BOM. Here is a better example of the indented BOM in particular. So at a top level, we're looking at an alternator here. At the next level down, we're looking at the stator 1.1. Now, if we're looking 1.11, the stator is made up of the frame and then the windings. So the frame would be like this orange part, and then the windings would be sort of that purple part, as you can think of it. So that way, if you filter based on anything that has a 1 in it, you'll see that that's the stator. If you filter by anything at 1.1, you'll see, or 1 is the alternator and it's all of its components. Anything with a 1.1 is relative to the stator. But I'll walk through an example of that dynamically, which I think is a little bit more easy to understand. There's also a useful distinction between two different types of BOMs. One is an E-BOM, an engineering bill of materials, and an M-BOM, a manufacturing bill of materials. So most people have only ever given thought to an engineering bill of materials because you're probably prototyping something that you ultimately hope somebody else will make for you, another contract manufacturer. And the difference here between the two is that an E-BOM doesn't include a number of other potential consumables that should be embodied in the cost of your particular unit. And that could be things like plastic protectors while used in transport from one assembly line to another, or shit from moving from one place to from your manufacturing facility to a packaging facility, packaging materials, different types of boxes, all sorts of random things like that. What's up, Mike?
So you said it would include like the things we would need, the cost of the things we would need to ship between assembly lines, which I get. What do you do? Would you model shipping into something like this itself? So like, per unit, it would be about this much, the actual shipping cost, or would you hold on to that separately somewhere else?
That is a really good question. And I would say that depends on what you intend to use your bill of materials for and sort of what stage your company's development is at. If you're looking to get a really good idea of what your actual unit economics are, then I would include it, especially if you are responsible for it. For instance, if you are having cases injection molded at one place, but your electronics PCB manufacturer is assembling them, then you would probably want to figure out and document how do the cases get from here to there and how much does that cost, especially when you have different potential configurations of coming from different suppliers. And if you're using, we're going to talk about this in a minute, but a flat BOM structure, this is where it gets really complicated because it's only two-dimensional. So you can't do multiple different analyses very effectively. So all of the potential permutations of cost that come from using this supplier over that supplier, and it's shipping from here versus shipping from China. And I would sort of create separate individual BOMs for each one of those cases and manage that in a specific sort of folder for that task of doing the analysis of
The exact use case I had in mind. Thank you.
Yeah.
Nailed it.
Awesome. But yeah, it's the manufacturing bill of material. So this here it says, which I agree with, it's probably MRL level 7 or 8, where you're going to start thinking about making that shift from an engineering bill of materials to a manufacturing bill of materials. Now, this would be different for sort of artisan manufacturing, or if you are actually setting yourself up to be the manufacturer. In that case, you would probably want to start considering these things earlier in the process because they're going to inform your design decisions. And if you make a design assumption early on, and then you find out later that it's a real burden to actually manufacture that and set up a manufacturing line, it could have been helpful to maybe start MBOM earlier, or looking at it that way. So here's an example template of the indented BOM. Again, we'll go through an example, which will be better. Now, another really critical task, which I think is oftentimes overlooked, and same thing with the PRD, the product requirements document. We mentioned this: change management and version control. The earlier you are, the more stuff is changing and more rapidly. And so I wouldn't recommend necessarily instituting a really rigorous change control process because you want to make those iterations quickly and not hold yourself up. But as you start to get higher in the MRL level, as you start to get closer to actual production delivery, you really want to be disciplined about documenting every single change that is made to your bill of materials on a sort of cover sheet so that you can really quickly and easily assess the difference between one and another. Especially if you're using Excel sheets and like a flat BOM structure, it's really easy to bury assumptions in the calculations in an individual cell that maybe are no longer valid. This is a great example of something where it's like, if you're cutting parts out of a sheet and you switch from one sheet size to another, and your cost could easily drop by half. But if you forget that that assumption was made and you change it, suddenly you'll wonder like why your cost dropped so much, and is it an error, or did you break a formula? Things like that. This is also absolutely essential for regulated environments, but that's where you'll start to potentially get into different software tools. So I'd mentioned this before, is sort of your entry level there is the Excel sheets or Google Sheets. I love Google Sheets because you can comment, you can collaborate, you can protect and share for different sharing privileges for different people. So it sort of allows you to set up a rudimentary version control system right out of the gate. The downside to that is it can be cumbersome for doing those types of analyses like I was talking with Mike about there, where it's like, if you have many different versions or many different SKUs of your product, which stands for stock keeping unit, and that is like my product, where I have essentially only 4 components: the housing, the water vessel, the cube tray, and the sphere tray. But that gives me 5+ different SKUs. I could sell the unit without a tray, the unit with a cube tray, the unit with a sphere tray, the unit with a cube and a sphere tray, And that's going to have different packaging, different shipping costs, different costs embodied in each one of those SKUs. So intelligently naming your sheets and organizing them in sort of folders is a really critical thing for if you're going to go that route and try to stretch it as long as possible. There are some pretty low cost or potentially even free tools out there, or software as a service tools, cloud-based systems. Parts Dashboard is one that actually started out of Rochester, New York, and it basically uses, it's essentially a Microsoft Access database template. And so by using a database, you can create a third dimensional association between any different components. And you can do stuff like, okay, I have 3 different suppliers for this component, and I want to dynamically change them and run a query to say, what will the price be with this change, and this change. Airtable is another example of a online cloud-based database system that can do stuff like that, where you can think of it this way: you can link a table with all of your suppliers, and then you can link another table with all of your contacts at those suppliers. And so then you can dynamically reference when you put a cell in that says, I want to pick between the available suppliers for this part. And you can link which one of those suppliers you can choose from in that cell, and then it can automatically pull up or roll up contacts, costs, things like that into a different view without having to change the data. Once you get sort of to the higher levels of production scale, managing multiple different product lines and thousands of SKUs and a pretty significant level of sophistication, that's when you start to get into an ERP or an MRP system. That stands for Enterprise Resource Planning System or Manufacturing Resource Planning System. They're oftentimes used interchangeably because the big names in the ERP game are SAP, NetSuite, huge global Fortune 500 companies that their enterprise software is very expensive, and they will tell you that it can do anything you need, but you're going to be paying for an implementation consultant to sort of set up a custom system for exactly what you want to use it for. I would not recommend trying to jump straight to one of these things. I would highly encourage you to not do that, to start with an Excel sheet, probably for way longer than you think you need to, because that will give you a greater understanding of exactly what you need to pay a consultant to set up if you do need a more dynamic system. So sort of the opposite end of the spectrum. There are some lightweight SaaS tools out there that are a hybrid sort of between they're starting to provide almost enterprise level connectivity, where it's like you can link a supplier and then it just will pull up all of the information from that supplier automatically, so you don't have to populate it all. One of those is MRP Easy. I don't have a lot of experience with all of these specifically, but I can definitely ask around if you have questions about it or looking for people with experience. Between the IW portfolio and Catalyst Connections portfolio, this is an example of something that MEPs, the Manufacturing Extension Partner Network, like Catalyst Connection, have a lot of experience with. So we'll talk about design packages in greater detail in the 6th session of this program. And that's things like, how does an electronics design package differ from a mechanical design package or a soft goods or textile design package, and getting all of this technical documentation together and bundled in a way that you need to get a quote, basically from an outsourced supplier. So that wraps up the BOM part of the discussion, and now we'll move on to the BOP, bill of process, or SOP, standard operating procedures portion of this. So that's going from what physically is your product to how is it built and what are all of the steps that go into making it, sort of the embodied energy cost of your product. Now, we'll talk about the different process flow diagrams, the costed BOP versus a SOP style BOP as well. But one thing that I will say just right out the gate is I don't think I've ever met a startup that has a bill of process or had ones done at the initial discussion. And I think that a big reason for that is because many people assume that their manufacturer will handle and develop this and for them. And it will then just be rolled up into the cost that that manufacturer can provide to you, and you won't have to worry about it. Now, that may or may not be a valid assumption, depending on what your product is, how complex it is, whether it has electrical, mechanical parts, what your specifications are. It's very complicated. And so I wouldn't recommend digging in and trying to complete a full bill of process, because it's something that takes a considerable amount of work and will change dramatically depending on your design decisions as you continue to iterate. So that's why I would say it's a good idea to start with a process flow diagram, which is a sort of overview, simplistic view of it, and then work your way into creating a more sophisticated full bill of process, as well as SOPs. So here's an example of a pretty generic, easy to understand process flow diagram for making banana bread. So we would start up here by assembling these ingredients. You move them to an assembly station. There are some sub steps ahead first, which is, mash the butter and the bananas together. That combination goes to the assembly station to start with. Same thing with the eggs. You got to beat them, make the batter, move it to a pan, bake it, and then you end up with banana bread. So that type of level of process flow diagram allows you to identify for things that can be done in parallel, what work in progress stages are there and how long does that take? So is there anything that can be done to streamline this process? Where do you want to put quality control checks in? Things like that. Useful for your general design decisions. Here's a bit of a more complicated bill of process, also for making banana bread. That came from the Build for Scale curriculum. So you can see here, there are different icons that mean different things. Tooling, a part, sub-assembly, pre-processed part, and multi-touch inspection steps, things like that, which in creating your own process flow diagram, I would, choose something that makes sense for you. But we also have provided in the process flow diagram template are some basic operations and diagrams that you might want to consider using. Another example of that, the one document has it in an Excel sheet. I also created a Google Drawing template, which I think is a little bit easier to use because you can more dynamically rearrange stuff and it's less resource intensive on your computer. But we'll go over that in the example. So the official definition of a bill of process is that it's a formal document that defines the step-by-step operations to make and assemble the parts for incoming materials, for everywhere from incoming materials all the way through finished goods. So also known as your overall process plan. Back to the banana bread example, it is the recipe section of the written out instructions section of it and of the recipe. That's where I would consider this to be a sort of SOP style bill of process that stands for standard operating procedure. So this is a document that you would put into place so that you could have that available for hiring new employees or swapping out employees as there's changeover. or in the case of using a contract manufacturer, it's something that they would either want you to already have, or more oftentimes they want to develop it for their own systems, given their understanding of how many different employees they have with different skill sets and how many different assembly lines they have that can operate in parallel. But it's a good idea to have a good place to start. This is a more tabular view of it, which I would call a costed BOP or a costed bill of process. And even this isn't a great example of it because it doesn't have all of the times on here. But the objective of this is the same way that you would use your bill of materials to identify and optimize your part costs and your manufacturing methods. So your design for manufacture, you would use a bill of process like this to optimize for assembly. So design for assembly, or some aspects of design for manufacturability as well, which we'll talk about in, I think, the 5th session of this curriculum in greater detail. But what are some things to include in your bill of process? Operation number and description. This would be sort of an analog to your part number on the BOM. A description of the process, so what is actually going to happen in this step. What resources are needed in order to complete that step in the operations. That could be the embodied cost of time, so both on the setup time and the cycle time. The labor in terms of what your actual hourly cost is for workers at that particular skill level that is required for that product. The location, if you're setting up, particularly if you're setting up your own manufacturing, or if you're relying on a network of suppliers, where is this actually happening? So then you can sort of identify transit time between steps. Equipment that is necessary, so tooling and fixtures, materials and parts used. So this is something that you would definitely want to link to your bill of materials. So that way, all of the documents are linked, and that if you are making one of the sub-assemblies in your bill of materials, you can reference a level and or a part number in your bill of materials to say, these are all of the things that are required to do this, and this is what will result from it. Now, moving on to the next level up of your assembly, these are all of the sub-assemblies that need to be moved into the next step in the process. And so then SOPs can be a subset of that tabular view, which I would look at as a sort of link in the table, where it's if a process description is not adequate enough to explain fully what's happening, like beat the eggs for your banana bread. That might be sufficient for you depending on what your quality control needs are. But if you really want to be super precise about it, you could include an SOP for exactly how to beat those eggs, using what tool, to what extent, how will you know when it's done, how will you know if it's a pass-fail situation, of whether those eggs are adequately whipped versus just the yolk is broken, stuff like that. So here's an example of a bill of process, which has sort of step numbers, the operation, where it is, what's happening. This SOP, in the old days, when everything was actually on paper, you would have to very intelligently name your document titles. And this would sort of correspond to an organization system in a filing cabinet as to where you could find each document in that process. Now you can just create a Google Doc and link it to that, but it still behooves you to have an actual rhyme and reason to how you name these documents so that they can easily be clustered and sorted together. I like this one because the units are sort of standardized all down to minutes. So that way you can total these up more easily to figure out what, clusters of sub-steps cost in terms of time. And then you could also add what your hourly rate is for that particular group of sub-steps to get a dollar cost to it. Here's another example of that style. Instead of just using whole numbers for the ID, they also use decimal numbers for sub-steps in that process. I don't like this because you can't add 30-minute clean and 5-minute per ton. That's another question that oftentimes comes up too is, it's easier to batch out a bill of materials down into one unit. But oftentimes when you're actually manufacturing, you're going to have to make assumptions on batch size because you can't just make one of something if you're going to be cutting out a whole bunch of parts off of a sheet. It's not always going to make sense for you to have those all inventoried in-house. So you just can say, okay, grab 5 of those parts for this one assembly. There might be sort of dependencies and assumptions that you're going to have to make in terms of how frequently can we do this and how long will it take to process it? How many units will that produce in that time frame? So even at the end of it, you then have to normalize it for batch cost down to your unit cost in terms of labor. Again, this is all stuff that your contract manufacturer, if you think that you're going to just not have to worry about this because you're relying on a contract manufacturer, technically true, but that doesn't mean that it's not going to come back to bite you in the ass. It's also why it can sometimes be a significant burden to get a quote on a product from a manufacturer, especially for what's called a box build in the electronics world, because they're not going to want to just throw a random price to you without having a good understanding of how complicated it is to successfully assemble that product. So if you don't have any of this stuff documented, you're asking them to do it and they're going to bake it into the cost that they provide to you. It's just something to consider when reaching out to suppliers and sort of negotiating. Sometimes they'll bill it out as a separate NRE cost for the development of that, or you could pay a specific product design company to just do that portion of the documentation for you. But I find that it's oftentimes easier. Most of the time, your product isn't that complicated, and you can get a pretty good idea, or manufacturing can get a pretty good idea, at least enough to give you a reasonable quote, especially if you're not particularly price sensitive. If you have bad margins, you can just send them a video of you assembling the product, and that can oftentimes be a way easier cut to the chase to get to at least a rough quote. But these are sort of nuances, all dependent on what your product looks like and how complicated it is. So recap of what's important for your bill of process, or why the bill of process is important. You want to make a bill of process is critical to ensure that your product is built the same way every time. It's critical to make sure that you have enough of all of the resources you need available in order to produce your product in a time frame that your business demands and with the resources provided. It's essential for certifications. So ISO 9001 is a certification you might have seen on certain manufacturers. They carry that certification, meaning that they have a bill of development process internally that conforms to the standards of the aerospace and defense industry. So basically, they can make airplanes, and the FAA won't come after them, or the FAA will know where to look for all of the things whenever they want to ask questions about how something was made. The same thing goes for ISO 13485 if it's a medical device. So manufacturers that are ISO 13485 approved means that they have experience developing and managing a whole quality program that conforms to the FDA's regulations. CGMP is more for like food products, and that's almost like the last level of regulation in my mind in terms of burdensome or overbearingness. But bill of process is critical for understanding your cycle time, your production rate, your labor costs, and if you are actually making your product yourself or trying to set up and scale your own manufacturing, or at least a portion of it, it's critical for your factory layout and material flow, identifying how big of a space you need to produce a certain, to hit a certain production rate of your product. And all of that folds into essentially resource planning. Just like with the bill of materials, this stuff can all be done on paper, or Excel is a bit better than that. And then databases and SaaS products are a bit better than that. And then if you really hit the big time, you can use enterprise software to manage everything. So best practices, your build process should include the same list of materials that's on your BOM, ideally all tackled with part numbers. The build process is designed in parallel with the product itself. So it is going to be a living document, and the amount of effort that you're going to want to put into that depends on your state. It's critical for identifying DFA opportunities, design for assembly opportunities, as well as your material handling requirements and variability in your process and assembly time. This is something that the U.S. Postal Service and UPS and FedEx are finding out with this time of year. Every year, you know, there's a bigger and bigger surge in deliveries. And so how do they manage a surge workforce that they have to train up in sorting and organizing and shipping and delivering packages to people, whenever it's, you know, 4 times the rate at any other time of the year? That's also can potentially be a reality of your business, depending on what your product is. Now, the build process is validated and tested primarily in the DVT and PVT stages of prototyping. So that stands for design validation testing and production validation testing. So back to the initial assessment overview, I just brought this in to say, basically, if you are at MRL 1 through 5, meaning you have a pre-engineering prototype, an engineering prototype, or an engineering validation testing prototype, or if you're in the pre-alpha, alpha, or somewhere in the beta testing phase of your product, you're probably going to want to focus more on a process flow diagram, picture and video documentation, not super wordsmithing every single part, not really doing like time studies of how long it takes you to produce everything. I would still recommend filling out a rough template to give yourself a general idea, because at this stage, you're probably also trying to identify what your unit economics are and whether it's feasible or not. This is one reason why consumer products are so difficult, and why a lot of the manufacturing and businesses in the US end up in the medical and defense sectors, because those are industries that have much higher margins. So you don't have to do all of this stuff at the early stages. You can just make some conservative assumptions and move on. However, if you are now at MRL 6, 7, 8 stage, where you have a design validation test prototype, this is definitely a looks like works like prototype combined, because you're going to be doing beta testing with actual users, ideally without shepherding them through the experience, to get real world feedback in a customer relevant environment. Or if you have a PVT, production validation testing prototype, this is where this is your final product being produced on a pilot line, or maybe it only has a few non-scalable, low-rate production components to it, but it's pretty much ready to go. You're sort of ready to order your first 5% to 10% of an actual steady-state operation production batch. That's where you're going to want to start really taking a critical look at your bill of process in the SOP format. If you're working with the manufacturer already, asking them for it so that you can read through it and see what they have developed, and see if there are opportunities for optimization or cost reduction. And it doesn't mean that the process flow diagram isn't as important. It's just you probably have already done it and worked through that sort of stuff. So things to keep in mind as sort of last summary of the bill of process: what materials you're using, what equipment is necessary to assemble it, what is the labor requirement for each one of those steps, and how can you use the bill of process to get an estimate of the cost of each step of the assembly and also sort of each part or component in your BOM. What is the most expensive assembly step in your process? So that is an expensive from a time perspective as well as just an actual cost perspective. Because if you can use cheap labor to do something, but it takes a lot of time to do it, it might not result in a high tangible cost, but it can limit your production rate if you suddenly get an order for 10,000 units, because then you're going to be limited into who you can use as a supplier. And so understanding it from both a time perspective and a cost perspective can identify opportunities for DFA, design for assembly optimizations. Also asking yourself, what is the priority right now for your business? Is it driving down cost? Is it improving production rate? Do you already know that your unit economics are feasible? As we sort of talked about earlier, as to what your margins are. What's up, Mike?
And then just to clarify, we're working with a contract manufacturer. You had mentioned something around that. The recommendation is to get a bill of process from the contract manufacturer to sort of probe at how they're putting it together. I know we've put forward a here's how you should build it, and we've done that collaboratively. But is this something I should be requesting from a contract manufacturer?
I think it depends on the relationship that you have with your contract manufacturer and how far along is that, and do you have any concerns with their production rate at that point? Is it something that needs to actually be managed, or is that a service that you are willing and able to pay for? Also, if you're not in a regulated industry, then you don't necessarily have to worry about it from the liability perspective. I was speaking more, I guess, for the earlier stage startups who are starting to approach manufacturers for the first time, or maybe they're sourcing components from, overseas or instant board manufacturers and proto labs and things like that, and they're assembling it in-house. It's useful to do time studies to figure out if it's even feasible for you to build out your in-house manufacturing capability versus to go to an outsourced contract manufacturer. At that point, going to a contract manufacturer, I would not recommend giving them exactly this is what we want you to do, because you've probably written that from the perspective of your small team. And their reality is that they're managing dozens to hundreds of customer relationships and fitting them into a production schedule with multiple lines. So you don't necessarily want to micromanage it from that perspective. And that's kind of what I was saying, is it's oftentimes more useful to have a YouTube instruction video of here's how to put together one product. Here's the assumption of all of the parts that you'll need. Cool. Good question. So last thing to consider before we walk through the example is process capability. So whenever you're talking about a process capability, it's similar to our tolerance discussion. If you're trying to cut something to 3 inches in length over and over and over again, it's not going to be exactly 3.000 inches for the scientists in the room with significant figures. It's going to be like 2.9, 2.95, 3.05 inches. The same thing exists in processes. And back to the banana bread again, the perfect example of that is if you are using a recipe for baking which uses volumetric measurements, so 4 cups of flour, number one, don't do that. It's silly. It's going to provide you with much more inconsistent results, because if you scoop the flour out of a bag of flour, that cup is going to be different than if you scoop it out of a bag of flour and then level it off. If you scoop with a spoon into the measuring cup and then level it off, if you scoop into the measuring cup and then pack it down, that's going to create plus or minus 20% variation in what the actual weight and amount of flour is in your banana bread, and that's going to then change all of your chemical reactions with yeast and the gluten and elasticity of your dough and all of that kind of stuff. So understanding what is reasonable with each process in the step of making your end product. What is reasonable in terms of process variation, and can your specifications accommodate that? And can your sort of part level or assembly level specifications be set in a way that narrows the band of process variation so that your overall product specifications can still meet your customer requirements? I think I just talked all about that, but back to physical parts. I love this diagram. It came from RIT, the Rochester Institute of Technology, of what is typical process tolerance for these different manufacturing processes. So these are measured in thousandths of an inch, which is a common parlance for machining. So you can think of this as 100 thousandths of an inch, or 0.1 inches, 0.05 inches, 0.01 inches, 0.005 inches, 0.001 inches, so 1,000th of an inch. Now, flame cutting, it's saying that basically its sweet spot is, around 50 thou or 0.05 inches. But if you're really careful with your settings and your specifications for that particular process, you can maybe get it down into these 20 thousandths range. But you're never going to approach what you can get from milling, which its sweet spot is down here into the couple thousandths of an inch. With CNC milling in particular care, you can get down into the thousandths or half a thousandths, but you're going to have to find the right shop and make sure you get the right specifications and define everything, inspect it regularly. Basically, what I'm saying is the further to the right side of this, the more expensive it's going to be. In general, these processes are more expensive and slower the further to the right they can be, but then even within each band here, the further to the right of that band, the more your price is going to go up. So yeah, I'm just a big nerd for materials and manufacturing methods as well. So honing and lapping is pretty cool. It gets down into these like micron ranges. That's like where they make optics and stuff like that. So, right. So homework for this session is take a stab at filling out a bill of materials. If you already have one, consider some of the things that we talked about and ask yourself if your bill of process has all of those. Same thing applies for the bill of materials, bill of process. I just totally switched those in and out. The product realization textbook has great chapters on this, on chapter 6 and 11, if you'd like some additional reading. And then the overview that I have also has links to the Build for Scale curriculum. So does anybody have any questions before I start walking through the example templates? But this is that curriculum outline that I said I dropped into the overall Google folder for the program down here. It has links to sort of each week's presentations, what the big topics were that were covered, what we'd recommend you check out as homework, reading assignments in the product realization textbook, and then links to the templates. I got to make sure that these links are actually all updated, and same thing with the Build for Scale links. But there's also a detailed outline which has even more specific breakdowns of what the sort of slide level topics were in these presentations. And this is a working document, so I'm updating that for the latest revisions as we go through it. But if no one has any questions right now, I can start going through, and feel free to shout out, raise your hand if anything comes up as we go through it. So this bill of materials template, which is in the folder here, We've got a bill of materials template, a flow diagram comparison, software comparison, so freeware and paid softwares that you can use to develop your process flow map, a process flow BOP, and the Google Drive or Google Drawing process flow map, as well as the presentation. And then I'll put a link whenever I upload the recording to Vimeo. I'll also put a link to this presentation in there. So the bill of materials template was developed by RIT. We got a cover page here, an introduction to how to use this, little call outs for specific areas of it, a blank version of that template. And then I started creating an example for a concept that I've prototyped and been kicking around for years, but haven't done anything with. I'm calling it the fast freeze system. So right now my product makes clear ice cubes by filling it up with water, putting the whole mold in the freezer, you pull it out, you take out the mold. This would be the world's fastest clear ice maker, something that you could sit on your desk, plug it in, and it would make an ice cube. Instead of in 24 hours, it would make it in 2 hours. And so what I've done here is focus first on, and I literally just did this today. So I focused on what my big sub-assembly or big systems are. And so we got the freezing chamber, power system, etc. Actually, what I'll do now is, as you can see, I haven't filled everything out yet, but I got some good nuances to just give you the idea of what some of these are. I see people getting closer to the screen, and I realize I forget that it's so hard to see when you're sharing in Google. They can't adjust the size here, so hopefully this is better. Now, one of the things that I really like in Google Sheets, and I'm sure you can do this in Excel as well, because it actually is an Excel file that I'm just opening in Google Sheets, is if you go to data, filter views, I created some preset filters for each major subsystem. So everything in the level 1 of the BOM is the freeze chamber, which I'm envisioning as plasma cutter sheared pieces of aluminum. So a long side, a short side, a bottom, open top, and a silicone mold that would go in there. Now, there are 2 of the long sides, 2 of the short sides, and then 1 of the piece of the bottom. Those would be welded. Obviously, the welding is not captured in the BOM because that is a process. So I would want to create a step in the bill of process that links to this level of the BOM to explain how all of these things come together. And in this stage, you can also use, I haven't figured out how I want to do the cost for this right now, because if I put the total cost of the top level, it will duplicate it for everything below that. But one of the nice parts about this is here's the quantity of each component, the units for that component. So this is more critical whenever there's a different variety of types of units, but the cost of one piece, so $2 per piece, $4 for both sides of the long side. I'm envisioning these would start out being made in-house, except for the silicone mold that would be a custom part manufactured by somebody else. The top level at 1 is an assembly. These are all assigned parts because I would need to set specifications for exactly what's going to happen in order for these all to fit together. I haven't created those specifications, but for these types of components, I'm imagining that a simple engineering drawing, a toleranced engineering drawing would be sufficient for somebody to get started. But you might also want to just link to a folder that contains all of the document styles for that. So not only your technical tolerance drawing, but also like an STL file, an IGES file, a SolidWorks or an Inventor file, because if you're going to use this to get quotes from multiple people, it can be a real pain in the ass whenever somebody's like, oh, I can't open an IGES file, I can't open an STL file. You have to go back into SolidWorks or Fusion or whatever your CAD packages to just create that and then send it in one email where you could link it into a folder here. A specification for the assembly level would be an assembly drawing is oftentimes very useful. Same thing with a link to an SOP or cross-linking between your bill of process and what section of your bill of process covers that. And then ultimately a link to a quality test plan document would also be good to include here. So how do you know that this was assembled correctly and will function critically? So from my perspective on this, it would literally be, does it hold water and does the mold fit into it? So two very simple quality tests, but if it's undocumented, nobody's ever going to know. A bill of materials like this can be very useful for getting quotes and organizing that information, but you're not going to want to send the whole thing to any given manufacturer because it would just overwhelm them. Things like this comment field would be one that you'd obviously remove because that can be can have sensitive information in it, but having different views set up like that is very important. So this basically, I think up to column N was what was mentioned in the presentation as being critical stuff that you should really definitely have. Everything beyond this are sort of the nice to haves depending on where you are in your development process. So sorted by percentage BOM cost, what material is this made out of? Is there a spec on that material? So not just aluminum, but 6061 aluminum, not just silicone, but Shore A, FDA, BPA free, FDA approved silicone. Something I found useful in my experience is weight and volume of parts. This is both useful in supplier parlance where they want to get an idea rapidly of, without having to open up every engineering drawing, just like, can I even make this? Do I have a press big enough to cut this or injection mold this? And if you don't have that written down, you're going to have to dig into the documents and give them that as an answer to the question anyway. Also, shipping and warehousing. How big is this thing? Do they have the space to actually even deal with, 5 of these, 50 of these, 100 of these? If you're asking for a quote for 10,000, they're going to be like, and it takes up an enormous amount of floor space. They're just going to be like, that's a no-go right there. I also find, especially for external communications, it can be helpful to already have like a picture embedded in here. So then they don't have to open up every single one. They can just get an idea of, okay, what does this assembly look like? What is he talking about? Here's your supplier's part number. Now this is different. This is something like, if you're going to order vinyl tubing, that's a generic component. If you put a generic component on there and list it as generic, you can put a spec on it that just says, must have this ID, must have that ID, must be biocompatible, or something like that. But if you want to buy tubing from a very specific supplier, you would then want to list that supplier, but also ideally list that supplier's part number so that it's very unambiguous. If they carry multiple different styles of like 5/16 inch inner diameter vinyl tubing, reinforced, unreinforced, different materials, stuff like that, it's easier to just look up their part number and put it in there. Who's your contact at that place? Where is it located? You can get as granular as you want with that, depending on what's actually important to you. Lead time, minimum order quantity, and I'm sure there's plenty more stuff in there. But I created this for each level of the enclosure, and then also one for sorting by BOM cost. So if you look at I think this one, I went down to a 3rd level, which if I wanted to, I could create another filter view that looks at specifically this 2.5 level and its sub-assemblies. Reason for that is because it's a power supply. In this case, it's COTS, So I would just buy a power supply, but it's $50 and you'll find that it's, 84, or this isn't accurate because this is sorting based on this subtotal cost. So the power system of this is $58.90, but the total BOM cost on this is $150. So looking at that power system, power supply, the power supply is 33% of the BOM cost. So if we go back to the sorting that by BOM cost, we can see that it jumps out at you right here that two of my biggest individual component costs are the power supply and an Arduino. Now, this is going to be something that's very typical of an early stage engineering prototype, is that you would use an Arduino. The thing is, if you look at an Arduino, and I need to actually fill out the numbers on this because it would be useful, but you could filter based on just the Arduino and see that, the Arduino has a bunch of, I didn't actually break it out, but I would have broken this out into a third level to list every component that's in an Arduino, and then you can identify whether you actually need all of those features. It has like 13 different digital inputs and outputs and 6 different analog inputs and outputs. It has its own voltage regulator on there so that it can provide power to things, indicator lights, all of this stuff that maybe I don't actually need. So that Arduino, which is nearly 20% of my BOM cost, could be a real target for making my own PCB to reduce that BOM cost. But it's never too early to start listing this stuff out, so you can identify stuff like that and assess whether or not it's actually reasonable for you to focus your time and engineering efforts on something that maybe this total is fine. If I want to sell this for $1,000, that's like 80% margins already. And so who cares? But can I sell it for $1,000? Or do I need to get that cost down? That's the stage of this, which I'd say is critical. Let's go over the process flow diagram. This is the process flow style BOP, which is created also by RIT, has these symbols which you can sort of just copy paste and create your own example in Excel, but my computer is already having trouble with that. Here's an example of one that's filled out. So I would recommend using if you use G Suite, the Google Drawing template instead, because this one can be a bit easier. Copy this, copy this, and actually link it. Didn't work. So it does that sort of dynamic linking and stuff like that, which makes it a bit easier than doing it in Excel. If neither of those options work for you, one of my former collaborators at Rochester at NextCore created this nice software diagram. So there's a whole bunch of different software templates out there that you can use to do this type of process flow diagram stuff. But the last thing I will talk about is here is one of the examples of the process plan, or a sort of tabular SOP that you could use to ultimately tabulate your labor costs. I didn't fill out this example yet, but I plan to in the near future, because I think it would be useful to get a better understanding of how you can estimate costs. So I think that about covers everything that I had for today. didn't leave a lot of time for questions here, but does anybody have anything they'd like to discuss or ask about?
I have a question. What are the things you missed in bill of materials and bill of process that have bit you the most in the past?
That's a good question. I think my product is deceptively simple, and that bit me more on the bill of materials side because I didn't have all of the specifications listed for what I needed that material to be. And then I didn't have a version control system. So when I would order from batch to batch, sometimes they wouldn't even ask about what I wanted to use. And if it was the same as the last, they would just assume it was the same as the last time. But I had made a change to the durometer of the silicone that I wanted to use, which improved usability. But because I didn't have an accurate version control BOM that I used every time that I ordered, things just get willy-nilly whenever you don't have a structure to it. I think the bill of process bites startups, more of the startups that we work with, specifically from the perspective of their unit economics. And especially if you're working in trying to optimize your supply chain and for scalability. It's well and good if you can make one robot in-house, but if you're not charging for labor, and then you get an order for 1,000, it becomes an impossibility.
Yeah. Thanks.
Yeah.
Get it.
I think Rohan, you're up next.
Yeah, so this is in the vein of what you just said about unit economics. I think a struggle that we have had, and I'm sure everyone may face at some point, is like when you look at your BOM and you look at like the highest priced items, that is dependent on the scale at which you're operating. And when you're calculating unit economics, a lot of the times, like for example, your Arduino, you may worry about it a lot right now, but I know based on my experience that like it's a part that's going to become very cheap long term. So do you have any general tips or guidelines on how to look at your BOM and understand or get better estimates of for 100,000, 10,000 units, what's going to matter and what's not?
That is a great question. And unfortunately, I don't have a comprehensive resource guide for that. That's something that honestly I would love to dig in with you on for specific things, because there's a certain amount of embodied knowledge that I have. And then there's also our sort of mentor network and other companies that I can then say, okay, I don't know this, but I know somebody who's dealt with a similar issue. We can ask them. Because another variable to that is time. Like, when are you doing this? And so if you're talking to somebody who used to manufacture a product 20 years ago, which was still in the 21st century, which blows my mind that like 20 years ago was still post 9/11, but that's going to be completely and utterly irrelevant right now. If you talk about somebody who has 5 or 10 years ago experience, like between shipping and supply chain issues and supply and chip shortages and stuff like that, these things are changing all the time. I think the best way to account for it on your BOM is to potentially, depending on your stage, either build that in with a cost band. What is your minimum cost that you're 80% sure that you can hit, and what is the maximum cost that you're 80% sure that you can hit? So that you then have a range for every different component, and you can sort of shrink those tolerance bands to make those assumptions. If we're talking general rules of thumb, I wrote a really comprehensive startup recipe about for injection molding, and
Right. Yeah.
Proto Labs has done a great job of creating an online calculator that can tell you about injection molding. Ultimately, there's a lot of different ways to work to back into it. But the only true way is to get quotes. And so the process of actually reaching out, getting multiple quotes, assessing whether or not they're tightly grouped or whether they're widely grouped. Because if they're spread too far apart, then you're going to be like, then you need to dig deeper to figure out why are they spread so far apart. Is it your specs are off? Is there just a huge variable here depending on location or what type of capital equipment they have? Because just in terms of circuit boards, like if you're doing circuit board assembly and you get a quote from a place that only has one circuit board line, it might be astronomical, but if you get it from a place that has 5, it could be significantly lower. But if you don't know what those differences are, you're not going to necessarily know. And if you do, you have time to actually dig into what is the specific part and the specific manufacturing method and the nuances associated with your specs? Or is it easier just to find a dozen people that could make it, reach out to them all, and then find out if you have a tight distribution or a wide distribution?
So what I'm hearing is there is no real alternative to getting actual quotes for some of these parts.
Not if it's critical. Not if it's critical to like your design decisions or your unit economics or business path.
And one last question on that: do you need to have the part designed for DFM before you get that? Because that takes time, and then if the manufacturer looks at it and like, there's no way we can make this using mass producible methods, some of those concerns are what make it harder to get good quotes.
That is a great question. I will say it is not worth it to stress too much about DFM in most cases, because a lot of DFM exercises are equipment specific, site specific, supplier specific. It's what they do all day, every day, whenever they make a part. And so if it's going to be something that you're tearing your hair out over, it's oftentimes better to focus on approaching a manufacturer as you would an investor. Build the relationship, sell them on the potential of this, sell them on your capability and ability to work with them on optimizing it, and most of all, the overall lifetime value of hopefully both the relationship with you and the relationship with this product. Some of the manufacturers that we work with locally that have been, I'm sorry, Stephanie, I didn't get to your question. Some of the manufacturers that we work with locally, Nick's on here, one of our local manufacturers, have actually expressed one of the biggest reasons why they are willing to work with startups is not necessarily because they believe that product is going to be a showstopper, something that's just going to make money hand over fist, but that they believe that entrepreneur or that business will have a good lifetime value for them. Because if it's not this product, it'll be the next product. And if it's not that product, they'll go to work for a bigger company that they'll be the purchasing manager for.
Okay. Yeah, that's helpful. Thanks, man.
Did I get that right, Nick? Would you agree?
I was eager to jump in. But yeah, I mean, Rohan, we are electronics contract manufacturers, so we hear this question, from startups day in and out. So as Matt said, that reach out to your contract manufacturers, ask for quotes, ask specific questions, why there is a variability in the quote. And over a period of years, we have developed certain templates. What presentation Matt gave is right on the money. So we have developed DFM checklist, DFT checklist. So we work with startups. 80% of the question, gets answered from those templates. So whoever you are working with, ask questions and then put them side by side with other contract manufacturers.
Yeah, thanks, Nick. I may get in touch with you because we do need electronics help.
Sure thing.
Yeah, thanks for jumping in, Nick. Nick is with Innovative Electronics. Any other questions or thoughts? Awesome. Well, if not, this falls into my block of open office hours, so I can stick around for anybody that wants to, or you can feel free to sign up for a time. Also, let me know if the availability that's out there right now is not sufficient, or it's at a time where you just like can never actually meet. But I hope this was helpful.
It was. Thank you very much, Matt. Have a nice afternoon. Bye.
Thank you, Dylan. You too.